Hi, all you math students back in San Diego. I'm standing here near the St. Francois River in Quebec, Canada. And I was thinking of going swimming, but this river has a current going that way of about 2 miles per hour. And I can only swim 1 mile per hour. So the river would carry me that way, and just down the river is this. Yeah, so I don't think I'm going to go swimming in here. It would really ruin my day if I went over those falls. So I'm going to just walk real carefully around here. I don't want to get anywhere near this river. So I'm not even going to look at this river. Oh, oh, it's going, making me go down. Oh, oh no. Oh, don't try this at home. Oh, that was a close one. Fortunately, these people lied to me, and the current isn't really 2 miles per hour. It's only about 1 mile per hour, and I can swim about 2 miles per hour, so I lied to you too. But it's hard to swim in a river. Watch when I try to swim upstream against the current. But now watch downstream. Okay, I rushed back here to California so I could show you what's going on with that river. This is the river, and I wanted to go up the river, and I could only go 1 mile an hour, so I'm going to represent that with this length is 1 mile an hour. So I make an arrow. It represents me. That's what I'm doing. The river is going 2 miles an hour that way against me. So if I start where, how far I would have gotten, and the river works against me 2 of these, 2 lengths. So here's the vector of the river. 2 miles an hour for the river, 1 mile an hour for me, and the difference, the amount I'm not going up the river, I'm going backwards. How much? Well, not 2 miles an hour because I'm trying to go that way, but the difference is from here as if I had gone this way, 1 mile an hour, because this 1 plus 1 equals the 2. However, really, I can go 2 miles an hour and the river is only 1 mile an hour. So let me represent that. I go 2 miles an hour. So my vector is from here to here. And the river pushes me back 1 mile an hour. So this is the river's vector, 1. And so I am going up the river, but only this much. 2 minus 1, this 2 minus the 1 of the river. Now what happens if I want to go across the river? So I'm going back to Canada and show you, because it's getting expensive, these airfares.
Oh, honey, I left my cell phone over there by those rocks. Would you be willing to go get it for me?
Oh sure, I'm stronger than this river, I'll just swim over and get it. I don't like the shirt on though.
You're drifting. I don't think you're going to make it.
Man, I don't know what happened. I thought I was stronger than that river. It took me right down there anyway. All right, well, now here we are back in California. So what happened when I tried to go across the river? Well, I went 2 miles an hour, just like always. So I'm going to show my vector there. I was going towards the rock to get the cell phone, but the river wants to make me go that way at 1 mile an hour. So I make a vector for the river, 1 mile an hour. Put a number 1 there to show the magnitude of the river. And this is 2, that's my magnitude. So where did I really go? Well, if I take from the tail of the beginning of my vector to the head of the other vector that we just combined with it, that's where I went. But I don't want to go here, I want to go here. So there must be some way that I can just swim straight across. And there is. And you will see this. I am going to do the angle up the river this way. No, that isn't what I want to do. I want my result to be straight across. So I'm going to angle up the river this way, and the river is going to force me this way, but that's where I want to go anyway. So the result will be, I hope, up here. Okay, I guess I gotta pay another airfare and go back to Canada and show you this. So let's go back to Canada. Okay, this time I'm gonna show this river who's boss. I'm gonna swim at a little bit of an angle up, aim myself up the river, and that should make me go straight over there. Okay, let's see if it works. Vectors should do their job.